this is an interesting problem. A man invested $6,000, part at 5%, part at 7%, using simple interest. His annual interest income is $372. How much money did he invest at each of the two rates? So I like to set up a little chart for this type of problem, and in the chart I have to take into account the amount invested, the percent or the rate that we're using to get, the interest rate, and then the value or the amount of interest I get from that. Basically, the amount invested times the percent equals the value of the interest that I'm going to get from a certain amount of money. And this is based on simple interest, so for 1 year we just do the interest rate once at the end of the year. So let's figure out what we know in this problem, and I'm going to set it up in a little chart here. Helps to organize and think about how much money I have. So the percents is the easy part. I have a 5% and I have a 7%. You with me so far? And amount invested, well, $6,000. Was it all at 5%? Was it all at 7%? No, that was the total. So I'm going to put that underneath for a minute. So that means I have to divide up the 6,000 between these two percents. But they don't tell me exactly how to divide it. So I really don't think I should do 3,000, 3,000. That would just be too easy, and I don't think that was intended. And when you don't know, that means let one of these values be x. Now, I'm going to let the 7% be the x. Now, if the 7% is x, the other part of the 6,000 would be found by going 6,000 minus x. For example, if I put 1,000 at 7%, then I would put 5,000 at 5%. But I don't know that it's 1,000, so whatever it is, I subtract it from 6,000 to get the other one. So here's our algebra representation of that. Now, to get the value, I have to take 5% and multiply it times this, 7% and multiply it times this. And when I add up those two values, according to this problem, I should get $372. So let's think about that. So if I multiply 7% times x, you remember when you multiply a percent, you have to change it to a decimal. So 0.07 times x. And what am I going to put up here? 0.05 times 6,000 minus x. Oh, look, this is an example of using the distributive rule. You remember that, right? Okay, so the equation that I have would be this part plus this part equals the total value. So now all I have to do is set that up and solve the equation. So let's do that right here. So that means that I would have 0.05 times 6,000 minus x, hope you have your calculator ready, plus 0.07 times x equals 372.00. We'll save the dollar sign for later. Now, the one thing I don't like about this problem is that we have these decimal points here. Well, you know what we could do? We could multiply the whole problem by 100 and get rid of that decimal point. You want to do that? All right. Well, here goes. Let me give a little more room here down below so we can work this out. So if I do 100 times 0.05, I get 5. So I have 5 times 6,000 minus x. If I do 100 times the 0.07, I get 7 times x. And if I do 100 times this number, it just moves the decimal point 2 places. 37,200. All right. Now I can solve this equation, right? 5 times 6, that's 30. 3 zeros. You have a calculator if you need it. Minus 5x plus 7x equals 37200. Let's subtract the 30,000 from both sides and combine our x's. So that would give me 2x equals 7,200. Divide that by 2. I get x equals 3600. So the question asks how much at each rate. So if I have 3600 here, how much do I have here? How do I figure that out? 6,000 minus that, right? 2,400. Double check, add these up and see if they add up to the 6,000. They better. All right, good luck.